So we're moving now from data to infrastructure, and that's certainly an area that's been affected by the Great Reset, with the decentralization of workforces, of services, and of customers, of course. And so to take us through the second of our expert insights, we have Chris Day, the Director of APAC Sales Engineering at Denodo, and his topic: a logical architecture is always a flexible architecture. Over to you, Chris.
Yeah, so the things that these four high-level capabilities, being able to be user-driven, to be secure, so that we're ensuring that the data stays within the organization rather than escaping, leaking out, being misused, and that the right roles are getting access to the right data for the right purposes. That we can accommodate technical change, new capabilities, new functionality within the data environment, within the information architecture, without disrupting business, because ultimately that's what we're supporting here, is the continuing business, the status quo that we want to happen. And then being able to cope with unexpected blows, being able to grow as required, but then also shrink down when it's not required. This might be to support specific operations or support specific patterns or times within the selling year. So all of these really, in my mind, come together as effective characteristics that data architecture must deliver. So why does this become a challenge for our organizations? Well, we can see here a really simple and contrived version of an information architecture where we have all of our data sources distributed across an environment, our on-premise data warehouses, our in the cloud software as a service, of course, file systems and individual shares. And on the right-hand side, we've got all of the different types of consumers, ranging from our reporting dashboards and BI through to machine learning, advanced analytics, and even interactive applications. And what ends up happening is that we build these point-to-point integrations. Why does this happen? Well, and rightly so, the business wants that data now. They want all the data, they want it now. And so as a technical community, we end up building point-to-point integrations. It's the easiest, it's the fastest thing that can be done in order to meet the demands of the user. But it becomes very brittle. It becomes really hard to start to change and evolve this, in that every time we do, there's the risk that we'll break something. Not only is there that risk, but it just becomes hard, difficult, even unmanageable to make changes to this in an effective manner, simply because that point-to-point has now distributed both logic and governance and security right across the environment rather than centralizing it. So this is where the logical architecture really comes into its own. If we have a look at where the logical architecture concept comes from, we can refer to Gartner. Gartner have, in this slide here, have shown that in the 1980s, organizations had one or two monolithic applications. And so getting that single view, that consolidated, unified view of all the data across an organization was quite easy. You would just go to that single application and get it. Over time, as databases and applications became commoditized, organizations ended up with more than one. And so to go from that distributed, fragmented view of analysis, the data warehouse was born. The way of unifying all of the data so you could get that unified analysis. As we then continue forward through time, we now have more data sources, more shapes of data, more repositories of data, data that no longer fits neatly into a row and column. And so to satisfy, again, the fracturing of data, the total distribution of data across multiple sources, the data lake was born, because now it becomes really easy just to put all that data back together without having to worry about the specific structure. And so we end up with an environment that has both data warehouses and data lakes, both which are really, really valuable and solve a lot of problems. So, you know, I'm not saying don't have a data warehouse and don't have a data lake. The issue comes about though is there is just an ever-growing number of source systems. There's an ever-growing volume of data that we're all well aware of, and the types of data. And so it's no longer practical to actually copy this data into a physical repository. And this is where the logical data warehouse comes into its own. The ability to connect to all of those data sources without actually having to copy them, relocate or replicate them. But connecting in such a way that they can be logically used. They can actually be delivered, used and integrated to deliver outcomes to our consumers. And so this really is that logical data warehouse, logical data lake, logical data store concept, where it logically embraces all of the source systems, whether they be on-premise, in the cloud, highly structured, semi-structured, or unstructured, to present them out through a unified interface rather than copying them. Moving to data virtualization, and specifically Denodo, this allows us to present out that logical view of the world. We can see here in this representation of the Denodo stack, across the bottom, we've got all of our different types of data sources, ranging from the highly structured data warehouses and relational databases through to the big data platforms, software as a service, file systems, even web services. All of these could be located either on premise or in the cloud, or as when it comes to software as a service in a provider. It doesn't really matter. The challenge being that how do we get those to the consumers, whether those consumers be self-service, reporting, dashboarding, machine learning, advanced analytics, interactive applications, even to our stewards and data owners. How do we get that out there? And this is where data virtualization comes into its own, because now rather than physically relocating all of that data to a physical repository, we can now logically present it out by taking the metadata, by using that metadata in order to build a logical model that presents out all of the entities and objects that the organization is using that can then be consumed by all of that. And so what's really happening here is we're unifying it in a single platform without having to do that relocation. The 6 key capabilities that data virtualization really delivers are these: the ability to abstract the storage and processing of the data from the actual consumption of the data. We can integrate all of the data regardless of where it's located or what shape it's in. This in turn then gives easy access to any of the data that's in our information landscape. And all of that unified metadata can be presented out as a data catalog that we can also use to do security and governance and data delivery in any format. Just quickly stepping through each of these 6 capabilities, that data abstraction means that now our consumers no longer have to worry whether that's the data that they're looking for or wanting to use resides on premise or in the cloud, in a relational database, in a web service, in a file system. It just totally gets abstracted out. In turn, this means that as we go through our digital transformation and modernization programs, we can literally plug and play new technologies in there without disrupting the consumption of that data. Then the zero replication and zero relocation of the data means that now we're not having the 15, 16 different copies of data in order to prepare the data and get it presented for use. We can ensure that we've only got the absolute minimum copies of data that are required in order to satisfy the regulatory requirement, in order to satisfy the historical requirement that we may have. This not only reduces the risk of data escaping, but it also reduces the costs required for just managing and deploying different levels of infrastructure. Being able to present the data in real time. This is the ability to connect directly to those source systems and get a real-time view of the data rather than introducing the latency required for copying or replicating that data into a new platform. And then self-service, as we're using metadata to connect and understand and build the logical models that are being deployed, we can also use that metadata to present that out to the users as a data catalog, so that now they can surf through the catalog, find the data that's relevant, even collaborate using the data catalog, and share information. The single point to go for all of the data requirements, rather than just having to wander through the information landscape and stumble across the data set that they actually need. That centralized metadata not only supports the data catalog, but now means we can have a consistent security model across all of those disparate data sources. We can also have a consistent governance model across all those data sources. So now when we say customer, we all know what customer is. When we say asset, location, whatever it may be, whatever entity or object or noun that we're talking about, it can be modeled and presented out with a consistent governance. And then the last one being location agnostic. So as we go through digital transformation programs, we understand that we'll have some data sets on premise, we'll have some data sets in cloud, maybe even across multiple clouds. And so being able to build a hybrid fabric, a hybrid presentation or unified layer across all of this becomes really, really valuable, because now we can be very strategic about where and what services we use, rather than having to be tactical in order to ensure that we don't disrupt the business. So just introducing a customer that we have that is leveraged data virtualization in order to enhance and enrich their business. This is Credit Agricole, one of the 10th largest banks around the world, does business in over 50 countries and has over 138,000 employees across the world. Their environment had thousands of different data flows across dozens of applications and warehouses and data lakes. You can imagine the sheer volume of data that they had. In order to manage this, they had hundreds of business processes and ETL flows, and it was just becoming quite a nightmare for them to manage. What Credit Agricole actually wanted was a platform that would allow them to perform unified analysis across all of the world, all of the different brands that they had, and a way that the users could be self-serving, could actually find the data that they want without the delays of having IT or the data owners stand up. And this had to be done in a framework that meant that governance was applied consistently and completely. If we take a look at Credit Agricole's environment, they'd already done a whole heap of work about unifying some of the disparate data sources into domain-specific systems. And they felt that in order to get to the next stage, they would have to build a data lake. So basically move all of these domain systems into a data lake. And then they would be able to very easily get that unified view. In doing some analysis, they found that this would not only be costly and complex, but the ongoing maintenance of this would just be prohibitive. And it wouldn't deliver on the requirement to be agile and timely. So what Credit Agricole did was actually use data virtualization in order to deliver this. Here we have all of their data sources, ranging from their file systems, their domain-specific databases and applications, and even external APIs. Using Denodo data virtualization, they were able to put a logical layer across this. So a logical data warehouse or a logical data lake. This enabled them to both manage all of the metadata of these disparate data sources, but also build consistent, well understood views of the disparate data. This now meant that the users could self-serve. They could search, understand and find the data. They could also then use the right tool for the job, so that the user is already very comfortable with Power BI or Excel or Cognos or Tableau could continue using that tool, but they would get a consistent view of the data. So not only was it able to be flexible about the underlying data sources, it could be also very flexible about the data consuming tools. The end result for Credit Agricole was that they were able to build this platform that supported both the specific applications and processes. So it meant that they could build logical data warehouses and do operational analytics and provide new data services. But they were also able to, without building another physical repository, present all of this data out as domain-specific hubs. So a high level of reuse, a high level of collaboration across all of these data sets. When we start talking about data virtualization and presenting out logical architectures, as we've seen for Credit Agricole, but also for all organizations that are looking at adding new capabilities to their information landscape, we can see that a logical architecture allows you to adopt new technologies without disrupting the delivery of data to the system. It prevents the requirement to build up specific data silos or data marts to satisfy a specific use case. We can now present those out logically, and so again, not having to copy or build up a specific repository. The fact that we're not building extra copies of data, extra silos of data across the environment in order to meet some business need or business capability means that we can improve the use, the collaboration across those data sets. Now, one physical data set could be used across multiple times, lowering the cost of managing that, and ultimately improves governance and security, because now we're presenting one single platform for all data consumption. We can also now ensure that we're having one single security model, one single governance model, rather than having the risk that one particular line of business or user group has a different model or a different governance. So that's a really quick overview and introduction of logical architectures and specifically data virtualization. But if you are interested in finding out more, I'd encourage you to download our Data Virtualization for Dummies ebook, which will step through in a lot more detail what data virtualization is, some specific use cases and patterns, and some more customer stories. If you're also interested then in having some hands-on experience, I'd encourage you to register for the Denodo test drive. This is free. It stands up a little sandpit in the cloud, and within an hour or an hour and a half, you'll be able to get an understanding of how Denodo works and what capabilities it delivers without having to install any software or configure any data sources. And you can run it as many times as you like. So something that I'd definitely encourage you to have a look at. So with that, I'd just like to say thank you very much. And I'm just wondering if we have any questions.
Yes, yeah, I think there are some questions that have come in through the Q&A stream, but just in the interest of keeping to our timetable, I might ask you to respond to those offline.
Sure.
But we do have quite a few that came through to you from the Q&A stream or during the presentation, so perhaps you could address yourselves to those.
No problem at all.
Excellent. Thank you so much for that.